Hello everyone and welcome back to the LeetCode grind. Today we have 1482 minimum number of days to make M bouquets. It says here you're given an integer array bloom day, an integer M, and an integer K. And we want to make M bouquets. To make a bouquet, you need to use K adjacent flowers from the garden, where the garden consists of N flowers and each flower position represents the day on which that flower will bloom. So each flower will bloom on that day, and they can then be used in exactly one bouquet. So return the minimum number of days you need to wait to be able to make M bouquets from the garden. If it is impossible to make M bouquets, then we return -1. Okay, so let's get this started here. First of all, if we can't return anything, then we'll return -1. So we'll start that. And then the main thing is we're given this plot. So this is a plot of flowers. These two are adjacent, these two are adjacent, and their goal is to find this number of bouquets that are adjacent of at least this size, or exactly this size. And they cannot be overlapping, meaning that this one flower cannot be used as part of this bouquet and this bouquet. Realistically, it can only be part of one bouquet. Okay? So the simplest way to do this is just by going through every number of days. So, from day 1 to it looks like day 10, we can check, okay, so let's say by day 1, can we satisfy this requirement? Let's see. Uh, we need 3 bouquets of size 1, and we have 1 flower that is bloomed on day 1. So that's 1 bouquet. So no, we cannot satisfy. And then we check day 2, and then ultimately we get to day 3. By day 3, can we satisfy this requirement? Yeah, we have 3 flowers that are blooming. And so, yes, we can on day 3. And let's say that day 4 was also, let's say that this, for instance, also had this. Let's say there was another flower that bloomed on day 4. Well, 4 is also a potential answer, but the reason we return 3 is that both on day 4 and day 3, we can satisfy this requirement, but we want to return the minimum number of days. And so we return 3. So that's the simple way, just going through every day possible. And the trick here is just to apply binary search on that number of days, where we set the minimum day as, let's say, 1, and the maximum day as whatever is the slowest blooming flower's day. So this flower blooms on day 10. That's the slowest day, so we can use that as our max. And then continue our binary search until we find the nth day where we are able to satisfy this requirement, at which point we continue our search, we update our res with that nth day because it is our potential answer, but remember, we're minimizing it, so we then continue search on the left, which is the lower half of the number of days. And let's say we're not able to make m bouquets of k size by that nth day, then we just search with the higher number of days. And let's say we don't find it, then we just return -1. Okay, so first of all, I will have a helper function that just counts how many bouquets we can make of k size on some day. Okay, so we're counting the number of bouquets, and remember that we care about the consecutive adjacent flowers. So we'll have that variable name as days. And actually, does that make sense? No. Let's say plot, consecutive plot. Okay, so we want a consecutive plot. All right, of k size. And then we can say we're just doing a linear, straight up linear search on every plot in bloom day, which represents a day, so we'll just call it a day. For day in bloom day, if that day, so let's say our nth day input was 3 and the day we're iterating is 1, then it qualifies. 10 does not qualify. 3 qualifies. Okay, if the day is less than or equal to our nth day, then you know what? That's great. We can include this plot in our bouquet because um, it's bloomed. So plot plus equals 1. And otherwise, that's okay. We just reset our plot because we want adjacent plots. So no problem. We reset our plot and say we haven't found it. And then at the end of determining whether the current plot qualifies to be part of a bouquet potentially, or if it doesn't qualify because it's not yet bloomed, the day it's not yet bloomed, once we determine that, we can also determine if the plots, I guess that should be plural, if the adjacent plots equals k, which is what we're looking for, then we're able to make a valid bouquet, so we can increment our count. And once we do that, remember, we don't want to use the same flower for multiple bouquets, so we just reset our plot to say we've used up this, don't use it again. And at the end of this, just return the number of bouquets we've counted in our search here. Okay, so now we have our helper function. We can continue our search with setting our left and right bounds as, let's say, 0 days and the max day in bloom day. So whatever is the slowest blooming flowers day. And then as long as these two don't cross, we'll say, we'll do the binary search on the day. So the nth day will be the minimum day plus the maximum day, integer divided in half. And using our helper function, we're counting the number of bouquets. We've gone through this logic. We're counting the number of bouquets we can make by this nth day. And if that happens to be greater than or equal to m, which is our target number of bouquets, then this is our potential result, and we update our result with this current day, this nth day. But remember, we are also trying to optimize our answer for the minimum number of days, so we don't stop here. We continue our search by setting the max day to nth minus 1 because we want to continue our search with the lower bound. And otherwise, let's say our count is not greater than or equal to our bouquet target count, then that's okay. We continue our search on the right half by doing nth day plus 1. And by this point, we should have either updated result or result is staying at default, and we can return the result. Give that a go and submit. And there you have it. Let me bring everything in one view. And once again, this was 1482, minimum number of days to make M bouquets. Thanks so much. Happy coding and hope to see you again next time.